Alright, this is chapter 6.5, problem solving. And we're looking at equivalent fractions. Alright, so whenever we solve problems, we have to find out what we need to find out. So what is the question is kind of what we're talking about. So we're going to start by underlining the question. Let me just get this. This what word looks like a question word. What other fractions could represent the part of the garden that has daisies? Okay, so we're problem solving, but we can't just start there. If we start with the question, we're not going to have enough information. So there's other information that's important too. And so you just have to read the question, and I would suggest reading the question at least times 2. Read it twice. So let's do that. Anya is planting a flower garden. It's not Anya, I don't know how to pronounce this. Anya is planting a flower garden. The garden will have no more than 12 equal sections. Okay, so now anytime you see a number, it could be that that number is important. So I like to circle it or underline a little section next to it. So this garden will have no more than 12 equal sections. And then here's another number. 3/4 of the garden will have daisies. Okay, so we're talking about cutting this garden, and it looks like I've got some pictures down below. This would be like her garden. And we have to cut it into what size pieces? Well, we're going to cut it into fourths. So she's going to make it into 12 equal sections, but we know that she's got 3/4 of the garden will have daisies, so we have to think about that. Let's read it that second time just to make sure that we understand it. Anya is planting a flower garden. Planting a garden. The garden will have no more than 12 equal sections. Now there are more than 12 little squares in here, but we have to cut it up. So we're going to cut it up. 3/4 of the garden will have daisies. So we're going to start. Let's start with 3/4. That's a good place to start. And then we have to figure out what other fractions could represent the part of the garden that will have daisies. And then we'll say, and then. Okay, so we're going to look for what other fractions are the same as 3/4. Okay, so this one is going to be a picture of 3/4, and we're going to cut this into 4 pieces. And the best way to cut it into fourths is to cut it in half, and then to cut it in half again. We could cut it in half this way, or we could do it like the book does it, and cut it in half this way. So we're going to have kind of these 4 rows, and if I just get real fancy and I just start coloring in, this is 1 section, 2 sections. I know you guys think I'm really fancy, but I'm not. 3 sections. That's 3 out of 4. That's 3 out of 4. 3/4. That's what it looks like. All right, so that's where we start. We started with 3/4. Now we don't have 12 equal sections yet, but we can figure out how to cut this in half. Okay, and I know that if I want to get 4, I'm going to multiply. 3/4 is the same as, what would I multiply by? I'm going to multiply by 3 to get 12. I'd multiply by 3 to get 9. So, you know, that's something. 3/4. I don't know why I have that multiplication sign right there. I might just go real back real quick, see if I can undo whatever mistake I may have made. How do I change fourths into 12ths? There we go. Maybe a little equal sign would be good. Well, I want to multiply by 3. 4 times 3 is 12. But I always want to multiply by a factor of 1, which is like 3/3 is equal to 1. So 3 times 3 is 9. Okay, so that's one of our options, but what if I had chosen to do something else? What if I had just started with something simpler instead of multiplying by 3/3? Multiply by 2/2, which gives us 6/8. Okay? Now you've done this before. This is part of the things you've already known. So can I cut this one into 8ths? This was our 3/4. Can I make 6/8, and then can I also make 9/12? All right. So sometimes we've figured it out using math, but now we've got to make our picture match it. So what if we went ahead and cut that in half and did it exactly the same way? This gets us fourths. Now that's what I had over here. But what if I need eighths? Now if I just cut every piece in half, I get twice as many. So now I have 6/8 as long as I color them in. Let's try it. There's 1. Oops, need to make sure I have my scribbly marker. 1, 2, 3, 4, 5, 6. Does that look exactly like my 3/4, just twice as many piece and half as big? Because they should be the same amount, and they really are. Let's try to change colors one more time, maybe a green or something. Okay, now we have to try to do it with 12ths. Now, can I go from, remember how here I had to multiply by 2 halves? So let's think about that for a minute. We multiplied by 2 halves to get 6/8, and we added 1 extra line. We cut everything in half, and there was twice as many. Over here, we're multiplying by 3/3. So instead of 1 line, we need to make sure that we have, instead of cutting each one into 2 pieces, we're going to cut each one into 3 pieces. And to do that, we're going to need 2 lines. But let's kind of just really slowly go through there. So first of all, we cut it in half. We get our 4ths, which is what we started with. So we had over here. Now we're going to cut each 4th into thirds. So if I do it like that, then it cuts each one of these into 3. Now what if I just extend this all the way across? There you go. And then you do the same thing, color it in. And you can see what we got. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9/12 right here. 9/12. All right, so what other fractions could represent part of the garden that will have daisies? Now we could do it more than just these 3, but these are the nice examples. All right, hope that works for you. So we took our 3/4 and we just cut each piece into equally smaller sizes. Here we just cut it in half again, which was times 2, and that made 6. Here we cut it into thirds, which is times 3, and that gave us 9/12. So that's something worth thinking about. All right, we're going to try one more problem, then I'll let you go. Okay, here's the second problem, and we're going to read it. We're going to read it twice, times 2. We're going to do that one more time. 2 friends are knitting scarves. Each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. If the friends are making 10 scarves, how many rectangles do they need? How many rectangles will have stripes? All right, so this is a little more complicated. So we're definitely going to have to try to figure out what all these numbers means. Let's start by just recognizing the question. The question is, how many rectangles will have stripes? And so let's back up a little bit now. 2 friends are knitting scarves. There's 2 people knitting. Each scarf has 3 rectangles. So each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. All right, so what would that look like? If the friends are making 10 scarves, so we need to know there's 10 scarves, how many rectangles do they need? All right, so first of all, let's just draw a scarf. A scarf usually kind of looks like a rectangle. Sometimes drawing a picture helps. Draw. Okay, so this is a scarf. Each scarf has 3 rectangles. So we would cut this into thirds. Does that make sense? So this is a rectangle. This is a rectangle. There's 3 rectangles. So this one looks a little too big. So maybe I need to move this over just a little bit. We'll try that again. Make it so that they look right. They're all the same. There's 3 rectangles here. 1, 2, 3. Each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. That means that if we just want to draw, 2 out of 3 of them have stripes. And if I were drawing a scarf, or if I were making a scarf, I might put the one on one end with stripes and put the one on the next end with stripes. So that's 2 out of 3 have stripes. Okay. If the friends are making 10 scarves, how many rectangles do they need? How many rectangles will have stripes? So each scarf Okay, so we're using our numbers. We drew a picture to help us understand, and we have to multiply this times 10 because there are going to be 10 scarves. Okay, so 10 scarves means that we're going to multiply times 2/3. This is kind of silly. All right, so can we figure this out? If every scarf has 2 rectangles with stripes, and every scarf has a total of 3 rectangles, that's from up here and we can see it, then we just need to figure out what is we got how many rectangles do they need. Oh, we have 2 questions. This is a complicated assignment, especially because we're not really adding fractions. We're kind of finding equivalent fractions, okay, but how many rectangles do we need? How many rectangles total? So 1, 2, 3 times 10. See, this is times 10. Alright, so hopefully this is making a little bit of sense. If we had 10 rectangle or 10 scarves, we would have 10 times 3 rectangles, because each scarf has 3 rectangles, equals 30 rectangles. And then, there we go, rectangles. And then we notice that 2 out of every 3 of the rectangles have stripes. And so how many rectangles will have stripes? Well, that's going to be 10 scarves times 2 with stripes equals 10 times 2 is 20 with stripes. And maybe we should flip this over so it looks like another fraction. So instead of 2/3, we're going to have 20 with stripes out of a total of 30 rectangles for 10 scarves. All right, so when the question says how do you make the answer? Well, there's 2 questions. How many rectangles do they need? Well, they need 30 rectangles, but how many of the rectangles will have stripes? Well, 20 will have stripes, and it kind of looks like a fraction of 20, 30. Or you could say, let's change colors just so that we can be less confusing. 30 rectangles, 20 of them will have stripes. Okay, now problem solving always takes a lot of work. You have to understand the problem, and it means, reading that problem several times. It looks like my page got bigger here. We'll just leave that for now. Good luck with the assignment. I will help you in class if you get stuck.